Okay, no warm up today, but we are going to go over the remaining problems that you were supposed to do to finish up on your sections 8384 worksheet, because you're going to take a quiz over the 8.4 part on telling whether or not parallelograms are rectangles, rhombuses, squares, or neither, or none of those. So while you're getting out your worksheet, you can continue to play this to remind you how we proved parallelograms were rectangles or parallelograms or rhombuses. And so this is what you took notes over yesterday. So if one angle of a parallelogram is a right angle, then it is a rectangle. So that's if you know they tell you in the directions that it's a parallelogram and they show you one right angle, then you would say that's enough to say it's a rectangle. Another way to tell, and that was part of the definition, because the definition of a rectangle said you have four right angles. And so in a parallelogram, if you know this angle is a right angle, you know opposite angles are congruent, so that would be a right angle. Consecutive angles are supplementary, so then that would have to be right angle. 180 minus 90 is 90, and so then that would prove that all of them are. So you can only do that if you already know that it's a parallelogram. If you're trying to prove if it's a parallelogram and they just tell you one right angle, you can't say it's a parallelogram on that. But if it's a parallelogram, they already tell you that, and then you know you have a right angle, then you can say it's a rectangle. So on the next one, if the diagonals of a parallelogram are congruent, then it's a rectangle. So again, we already know it's a parallelogram, and how they show us that the diagonals are congruent is they show us that all four of these pieces are the same. Because remember, in a parallelogram, diagonals bisect each other. So they cut each other in half. So if this whole length is equal to this whole length, then that means when they cut each other in half, all four of these pieces are the same. So if you know a parallelogram has diagonals that are congruent, then that's a rectangle. And that's nothing new to learn because that's what we learned one of the characteristics of a rectangle is. Okay, so those were the two ways that you could go further and say that a parallelogram is a rectangle. So proving a parallelogram is a rhombus, you've got three choices. First one, if one pair of adjacent sides of a parallelogram are congruent. So we already know it's a parallelogram, and adjacent would be two sides touching each other. So if they showed you a picture like this and said it's a parallelogram, then it's also a rhombus. Because remember, in a parallelogram, opposite sides are congruent. So this side would be congruent to this side, so I could put a single slash there. This side would be congruent to this side, so I could put a single slash there. And the definition of rhombus says you have a quadrilateral with four congruent sides. So if they give you just two adjacent sides in a parallelogram, it's a rhombus. Next, if the diagonals of a parallelogram bisect the opposite angles, then it's a rhombus. So if I draw this diagonal and it cuts these angles so that these angles are congruent to these angles, and then if I draw this one in, these angles would be congruent to these angles, then, and I know it's a parallelogram and it's marked like this, then it is a rhombus. And that was one of the characteristics of a rhombus. So again, that's nothing new to learn. And the third one, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So again, we already know it's a parallelogram. And if they show you that the diagonals are perpendicular in that parallelogram, then you can say it's a rhombus. Okay. So rectangles had two ways to prove that it is a parallelogram is a rectangle, and then to prove a parallelogram is a rhombus, you had three ways to choose from. So then on your homework, numbers 5 through 8, you had these directions. You have a parallelogram, so they already tell you it's a parallelogram. So that's important information. So then we can go on, depending on what information they give us, we can decide if it's a rhombus, rectangle, or neither on these. And when it says theorem, you're just telling me why. You don't have to give like the name of a theorem. So like for instance, on this first one, I'm going to draw CLPK. And when you go to draw this, and it's in the order CLPK, you start at one vertex and either go clockwise or go counterclockwise. But you can't go diagonal and put CL, then P, then K. That's not properly naming it. And then diagonal CP and LK that intersect at point X. I'm not going to draw that particular piece in because right now the only given information said that measure of angle K is 90 degrees. So I'm going to put a box there. So since they told us it's a parallelogram and I have one right angle, then which one is this going to be? you should be saying rectangle. And then when you justify your answer, you would say because the parallelogram has one right angle. Okay, so that was one of the ways to prove that a parallelogram is a rectangle. Okay, all right, on this one again, so CLPK. And notice in here it doesn't say anything about X, so I'm not going to draw on the diagonals. I don't need those. It says segment CL is congruent to segment LP. Okay, so it's a parallelogram, and this is where you have two adjacent congruent sides, so which one is that? That should be a rhombus. And so to justify your reason, because one pair of adjacent sides in a parallelogram is congruent. Okay. All right, and then I'll sketch this again. CLPK. CL is congruent to KP. So again, I don't need to draw on the diagonals since I don't have anything with X in there. So CL congruent to KP. Is that something that proved that it was a rhombus or a rectangle? No, that was not one, so you would say neither on this one, because there's not anything that would prove that that's a rectangle or a rhombus. Okay, and then this one I'll have to draw over here. So CLPK and KLC. And so since it's talking about angle KLC, I need to draw in my diagonals. And they intersect at point X according to the directions up there, intersecting at point X. So KLC is this angle, is congruent to KLP, and PCK is congruent to PCL. So I can put marks there. Now, since it's a parallelogram, that means this whole angle L is congruent to this whole angle K. So if this diagonal bisects that angle, it's also going to bisect this angle. So even though they didn't tell us that, I'm deducing that from the information given. Since it's a parallelogram, opposite angles are congruent. So if this diagonal bisects this angle, it's also going to bisect this angle. Same here. This angle C is congruent to this angle P because in a parallelogram, opposite angles are congruent. So if this diagonal bisects this angle, it's also going to bisect this angle. So then this is a rhombus because the diagonals of a parallelogram bisect the angles. Okay. So those are the answers that you should have gotten on this particular part of the worksheet. And then on the last one, number 9, that we haven't gone over, because we had gone over 10 and 11 the other day, refer to parallelogram KLMN. So again, we know it's a parallelogram this time. It's not just any old quadrilateral, but it is a parallelogram with diagonals KM and NL intersecting at P. Draw a picture. This time we're trying to see if it's a square. And remember, for it to be a square, it has to have markings that tell you it's a rhombus and markings that tell you it's a rectangle. So then I'm going to draw my picture, KLMN. And this is showing me that KN is congruent to MN. So I'm going to put slashes there. And KM is congruent to LN. So that is the diagonal. So from K to M, that's congruent from L to N. So those are the diagonals, and they're telling you that the diagonals are congruent. So how we mark that was this way, because in a parallelogram, diagonals bisect each other. So if the diagonals are congruent, that means all 4 of these pieces are congruent. Well, what was this marking when you have adjacent congruent sides? What was that? That was rhombus. Okay, and which one said that the diagonals are congruent? That was a rectangle. So this is a square because the diagonals are congruent and adjacent congruent sides of a parallelogram. So again, this hinges on knowing that it's a parallelogram first, then you can go further and say whether it's a square in this case, or the previous problems, rectangle or rhombus. The first 4 problems that you did on this worksheet, you just had quadrilaterals and you were proving if those were even just parallelograms. So those were different characteristics than the ones that we just talked about today. Okay, so what you're going to do is you're going to do the back of the quiz that you did on Monday. And so we're going to redistribute those quizzes and you're going to do the back problems. I haven't graded the front problems yet. So if you would like to go back and think you need to change something that you did on numbers 1, 2, and 3 when you were trying to decide if they were quadrilaterals or parallelograms, you can do that. But then you do need to do the 2 back problems because now we've finished that quiz for section 8.3, 8.4. Okay? So go ahead and close everything up and just take out a pencil. You don't need a calculator for this one. And then you're going to finish the back 2 problems of the quiz that you took yesterday. And then if you would like to change anything on the front, you can if you feel like now you understand something maybe that you didn't yesterday.